time for some more graphs. This time it's going to be graphs with log function. And then we're mainly going to focus on the transformation. So try to follow along with my arrow. Now, the red graph is the graph for log of x. So right now there's no transformation. And if you try to tie it into exponential functions, we were talking about domain and range. So you see that this graph right here is going along the y-axis. Well, if I were to zoom in, and you have to zoom in very close, you can see that there is a gap between the graph line and the y-axis. So it's pretty much like exponential function, where it looks like it's going along a certain y value, but it's not actually touching. So here in the log function, it looked like it's on the y-axis, but it's actually just going along the y-axis, not touching, not crossing. So this is basically the left side, bottom half of the graph. Now, if we were to focus on towards the right, upper side of the graph, so here, you can see that the graph is increasing its y value, going up, but at a slower rate. But as the x value is increasing, as you can see right here, it's increasing, but the y values is slowly increasing. So versus with exponential function, the y value increases dramatically while the x value is slowly increasing. So it's the opposite around for a log function. So again, for exponential function, the y value increased dramatically a lot when x value is slowly increasing. Here with log function, as you can see, the y value is increasing slowly, meaning that as x values increase dramatically a lot, our y value is slowly increasing. So the opposite properties or the opposite way when it comes to exponential function. Now here, we notice that there's a x-intercept, 1, 0. So that's going to be typical when it comes for log of x. Now let's talk about the transformation when it's inside the parenthesis x plus 2. Let's see what's happened. So I'm going to turn on log of x plus 2, and then that's the blue graph. So it seems that it's shifted maybe 2 units. So let's check. I'm using this x-intercept of the blue graph, which is the log of x plus 2. And then I'm going to compare it with the x-intercept with the original red graph, log of x. So if I were to compare the two intercepts, the x-intercepts, I see that from the red to the blue, it shifted 1 unit, 2 units. So for this graph, it shifted 2 units to the left. So it's pretty general as the other function that we covered in 1.5 and the exponential. Now let's see what happened when it's log x minus 3. Minus 3, that's the opposite of plus, so maybe it goes to the right. 3 units. Let's take a look. So versus with the original red graph and the green graph, which is for log x minus 3, it did indeed go to the right. So let's take a look. Our original red graph, the x-intercept is 1, 0. Now if we look at the x-intercept for the green graph, it's 4, 0. So if we look at the difference, 1, 0 and 4, 0, the difference of the x values is 3. The y value is the same. So we only look at the difference at the x value, and we did see indeed that the graph did move to the right, but 3 units. 1, 2, 3. So that is true. So to sum up when there's a transformation inside, if it's plus 2, now again, inside the parenthesis, if it's plus 2, it moves to the left. If it's minus 3, it moves to the right. So again, plus 2, move 2 units to the left, minus 3, move 3 units to the right. Now, what would happen if instead of just inside a parenthesis, it's outside? So now you have log of x plus 4. What would happen? So I turn it on, it's the orange graph, and if we look closely, we see that from the red to the orange graph, it's shifted upward. Now, so again, I'm going to compare the x-intercept from the red graph. So right here, the x-intercept, 1, comma 0. And then since it moved upward, maybe I could use the same point along the same axis, the y-axis here. So I'm going to use the vertical, and I'm going to check right here. So the point from the orange graph is 1, comma 4. So the x values are the same, but the y values change. So if it's just the y value that changed, that means that it's shifted only up or down. So if I compare from the red graph, the y value was 0. And if I were to compare with the orange graph, the y value was 4. So from 0 to 4, it increases by 4 units. So if we were to look at the graph, from the red graph to the orange graph, it shifted up by 4 units. So if we were to look at this, if it's outside the parenthesis of log, then plus 4 basically means it shifted up 4 units. So let's talk about when it was log of x minus 1. So since the previous graph was plus 4, up 4 units, minus 1 will be the opposite, down 1. Well, that's true. So we see that from the red graph to the purple graph that it went down. Let's see how many units. So again, I'm using the x-intercept of the original red graph. So 1, comma 0. And then if I were to look at this, so now our point is 1, comma negative 1. And the reason I did that, I lined them up vertically. And then we notice that the y value changed. The x values were the same, but the y value changed by 1. So it went from 1, comma 0 to 1, negative 1. So it went from 0 to negative 1. So it decreased by 1 unit. So when it decreased, it went down 1 unit. So if we were to look at the function log of x minus 1, so it went down 1 unit. And as you can see, all this is the same width, same distance. So it went down 1 unit. Now, as you get used to transformation, you can see where to look to compare the distance, the points, see if it actually shifted left, right, down, or up. All right. So that's pretty much the transformation when there's a number inside the parenthesis. So in summation, if there is a number with the x and inside the parenthesis, then it's generally shift either left or right. Now, if there's a number outside the parenthesis, like adding 4 or minus 1, it generally shifts up or down outside the parenthesis and after the x. So if there's a number inside the parenthesis with the x, like x plus 2, x minus 3, it generally shifts either left or right. If there's a number outside the parenthesis and after the x, then it generally moves up or down. Now let's talk about if there's a negative in front of the log function. So again, here the red graph is just typically the log of x. But what happened if it's just I take it back, negative log of x? So it will be the same transformation as the one before from 1.5 and it's the exponential function. So here's the black graph. So let me turn off and then turn back on. So here's the black graph, and it seemed that it flipped or reflected over the x-axis. Because if you look at the bottom of this black graph, it's pretty much the same as the top of the red graph. So it flipped, and then as you can see, the black graph is going along the y-axis, just like the red graph going along the y-axis, but in different directions. The red graph is going downward, vertically downward, while the black graph is going vertically upward. So if you compare the sides, they're in opposite directions, opposite side. So if there's a negative in front of log of x, then you can see that it reflected over the x-axis. But let's compare with another example. So this one was just a negative in front of log of x. So we did log of x. Let's compare with a different function. So let's say we're going to do log of x plus 2. So log of x plus 2. If I were to turn on negative log of x plus 2, what would happen? Then we can see that the graph did indeed switch sides. So we see the top of the blue graph is now on the other side of the axis, the x-axis. It becomes the bottom of the red graph. And then if you were to look at the left side of the blue graph, you see that it's going from right to left, it's going downward, vertically downward. Again, so if you were to look from right to left, it's going vertically downward for the blue graph. Now for the red graph, if you were to go from right to left, you can see that the graph is going vertically upward. So the changes from these two graphs is that it's going in opposite direction. So the top of the blue is now the bottom of the red. And then the left of the blue graph is going vertically downward, while the left of the red graph is going vertically upward, so in opposite direction. So with the same transformation inside the parenthesis, if there's a negative in front of log, it's going to reflect over the x-axis, as you can see. Now, it seems that it's not continuous, because if you were to look at the left side of the red graph, it does not go all the way up for the y value. So it stops. And then you can say the same for the blue graph. It didn't go all the way down. It's not continuous all the way down. So there's a certain stopping point for the blue graph. So that means there's a certain stopping point when it comes to log of x plus 2 and negative log of x plus 2. So if there's a negative outside a function, meaning in front of log, it's going to reflect over the x-axis. Now, let's talk about when there's a negative in front of x, inside the parenthesis. So again, in front of x and inside the parenthesis. So I'm going to bring back log of x. And then now I'm activating log of negative x. So as you can see, it just basically flipped over the y-axis. So from the red to the blue graph, it flipped or reflected over the y-axis. So it's pretty much the same transformation from 1.5 and exponential function. So let's take another look when we have another number inside the parenthesis. So I'm going to use log of x plus 2. So here's the blue graph. And then if we were to compare the x-intercept, the x-intercept for the blue graph is -1, 0. Now, what we use is negative of x minus 2. So again, I'm going to turn it off, and then turn back on. So it seems there might be a relationship between the blue and the green graph. So if I were to look at the x-intercept of the green graph, it's 1, 0, 1, 0. Now if I were to look at the blue graph, the x-intercept, it's negative 1, 0. So the change was the x values. They switch opposite signs. And that's typical when it's reflected over the y-axis. The x value changes sign, but the y value stays the same. Now, the reason we have for the green graph negative of x minus 2, negative of x minus 2. So if we were to distribute the negative, it becomes negative x plus 2. So just similar to this one, x plus 2, but this time the negative is just only on x. But the reason we keep this format, negative of x minus 2, because if we were just negative x, which I'm going to bring back as the blue graph, let me turn off the other one. So the blue graph is just typically log of negative x. And if I were to compare it with negative of x minus 2, we know that the negative in front of x is going to be reflection. But what happens when it's just x minus 2? If we were to focus that, we will see that from the blue graph to the green graph, it shifted 2 units to the right. So again, I'm looking at the x-intercept of the blue graph where it's just log of negative x. The x-intercept is negative 1, 0. If I were to look at the x-intercept of the green graph, so I see that it's 1, 0. So you can see that the x value changed, but the y value stayed the same. So we can see that it shifted 2 units to the right. So 1, 2. That's why the x value changed. Now, before, when we were talking about reflection, the x value changes sign, but the y value stay the same. So when you're graphing, or if you're looking at the graph overall at a bird's eye view, you can see that both sides of the graph are going in opposite directions. So for example, the blue graph, the top of the blue graph is going towards the right. Now the top of the green graph is going towards the left, so in the opposite direction. And if we were to look at the blue graph, it's going vertically downward on the left side of the y-axis. Now on the green graph, on the right side, it's going vertically downward. Now on the right side of the y-axis, so they're on opposite directions. So you can see that it did indeed flips over the y-axis, or reflected over the y-axis, or reflected across the y-axis. But let's take a look at another graph. So say we're going to use log of x minus 3. Okay, so let me zoom out for a bird's eye view. Now, we have negative of x plus 3. And the reason we have it in this format was because if we were to distribute the negative, it becomes negative x minus 3. So it's very almost identical to x minus 3. If we were to distribute this negative, it becomes negative x minus 3. Over here, it's just positive x minus 3. But we keep this format, and you'll see why again. So if I turn on this graph, we see that now on the green graph, if we were to go from left to right, it's going in the right directions. Now for the orange graph, from right to left, it's going towards the left in the opposite direction of the green graph. But the left side of the green graph is going vertically downward. Now the right side of the orange graph is also going vertically downward. And then as you can see, they're on opposite side of the y-axis. So again, if I turn it off and then I'm going to turn this back on, you see that it flips, it reflected over or across the y-axis. Now if I were to compare the x-intercept, the green graph, which is log of x minus 3, the x-intercept is 4, 0. And keep in mind that the graphs are going in opposite directions. If I look at the x-intercept of the orange graph, it's negative 4, 0. The x value changed sign while the y value stayed the same. So if you see that the graphs are going in opposite directions, the x value changes sign while the y value stayed the same, then it was basically a reflection over the y-axis, or reflection across the y-axis. Now, again, we keep this format is so that you can see that x plus 3, that it's going to shift 3 units to the left. So let me turn off the green graph. Now, if I were to type in log of x plus 3, oh, hold on, minus 3, but it's reflected. So you see how it changes that. Now, technically, I didn't have to type this because I could use log of negative x. So let me turn this off. So here's log of negative x. So if we use that as a starting point, now if we compare it with the orange graph, so let me turn it off, and then again, here's the starting point for the blue graph. If I have negative of x plus 3, then if I turn it on, you can see that the graph did shifted to the left, but how many units? So if I use the x-intercept from the blue to the orange, so it's negative 1 to 0, so negative 1 comma 0, and if I check it again on the orange graph, it's negative 4, 0. So the only thing that changed was the x value. So it went from negative 1 to negative 4. So it's decreased by 3 units. So meaning shifted 3 units to the left. So let me get this out. Here it was just negative x. Now here we kept it in parentheses so that to emphasize that it was a reflection over the y-axis, but at the same time it was shifted 3 units to the left. So that's why we have it in parentheses. So that way you can see that when it's x plus 3 inside the parenthesis, it means that it's shifted 3 units to the left, while there's a negative outside the x, but in front, it's a reflection over the y-axis. So again, or to sum it all, it seems that it has the same transformation from all the function in 1.5 and the same transformation when it comes to exponential function. So to sum it all, if there's a number inside the parenthesis with the x, so x plus 2, x minus 3, generally it shifts to the left or to the right. When there's a number after the x outside the parenthesis, it shifts up or down. When there's a negative in front of log, it's going to reflect over the x-axis. When there's a negative in front of x inside the parenthesis, inside the outer parenthesis, then it's going to reflect over the y-axis. Pretty much the same transformation as all the other functions we had covered before.